So when we look at congruence, you said it before, two triangles where the angles are the same and the sides are all the same. So these sides, these sides, these sides. That's what I mean by congruent triangles. Does everything have to match, though? Do all three have to match? All angles have to match? Yes, but do we have to prove every one of those? No. We can shortcut it a little bit by looking at these four. And the four are side, 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 just as it sounds. You have pairs of sides, pairs of sides, pairs of sides. If you can show that those three are, then the triangles are congruent. They might, I may have not done the same order here. And then for angle, side, angle, let's say you have an angle here, and then you have an angle out here, and then there's a side in between that's congruent. That'll work. The right angle theorem is kind of a response to the side-side angle, is that when you have a right angle like this, and then side of a leg, and then a hypotenuse, that's all you need. But it doesn't work for every triangle. Let me show you why. Why doesn't side-side angle work? This will look familiar to you. Let's say we had two triangles where the angles were the same. And this side here was the same. So this angle's the same, this angle's the same. And then not the one down here, because if this one down here was congruent, you're stuck. It's going to be congruent, side, angle, side. But let's say it's the next one. Let's say it's this one out here. This one is congruent to this one. Does this look familiar? When we did the law of sines, remember you could swivel this one two different ways. You could swivel it here or swivel it here. It won't affect the angle, won't affect this side. These are the same. This swivel situation is why you can't say side-side angle or angle side-side. Does that make sense? Yes?
So then does it work with a right angle because all the angles have to be smaller?
Correct. So let's say this angle, let's say you had a right angle, and then you have, so you have these two, but it's a right angle, and then you have the hypotenuse the same, and then either one of these sides the same. Let's say you have this one the same. Well, because this is a right angle, what do you know about if you knew these two were the same and these two are the same? Pythagorean theorem says what should happen with these two? Same. So it's Pythagorean theorem why that's going to be, that's going to work. But Pythagorean theorem or law of sines doesn't work for this other one. So side-side angle is the one that doesn't work. It's a bad word if you do it in reverse, so it's the bad relationship 1, 2. And then these four are the ones you're going to use. Let's practice a few. Here's one. Determine whether each of these figures is congruent or not. Let's take a look at this one. Here you have this angle and this angle are congruent. And this side and this side are congruent. What else is congruent? The middle is to itself, right? So now you have side, angle, side. Is that one of the congruent?
Yeah.
Yeah. And what's great about that is that now that you know they're congruent, you can say that any of the other corresponding angles or sides are congruent. And that's how we'll use this. Tell me if B is congruent.
No.
These two are congruent to itself. These two angles are congruent. I like what you're saying, yes. This would definitely be a side-side angle, and you know, this image could be lying to us, and so yeah, this is, you can't conclude that those are congruent. What if this was 90? Then you'd be good. All right. And then this last one, you can see how we would use this. Use congruence to prove that a bisector of an apex of an isosceles triangle bisects the base. So who had bisect in this one, in this group? Anybody have the bisector? Ben, did you have that one? Parallel. Who had the bisector one? Amanda, you didn't have the bisecting one?
I had alternate angles.
Ooh, that's a good one. Well, bisector means put your hands like this, bring your elbows together, and then go apart. If you want to find that bisecting angle, it's the angle that's right in the middle there. And what happens to the angles in between? Here and here. They should be equal, right? So when we bisect this angle, and this angle are the same. It is an isosceles triangle, so we're saying that these two are congruent. And then do we have anything else that's congruent? The middle part is congruent to itself. Well, that's what we're trying to prove. Correct. So if you have side, angle, side, now the triangles are congruent, and since the triangles are congruent, you can say that these sides are now congruent. Therefore, it bisects that base. Are you okay with that? We're going to play around with these and give you a chance to really dig into these. 1A through H. Here's what I want you to do. I want you to say, are they congruent or are they not? And then tell me the reason that they are congruent or why they are not. Give you a little time for this one. Gavin, why don't you tell me about this first one? You have angle, and then you have these two. These two, what is that?
Side angle, side.
That is side angle, side. And so those are congruent. Very good. How about Gabrielle? How about this one? Yeah, this is side angle. So this one is a no-go, not congruent. How about C here, Ben? Yeah, my favorite one. Side. Where'd you get the third side? The one in the middle is the same to itself. So this is side, side, side. Those two are congruent. How about Evelyn there in D? Yes. Yep, the middle. So you have side. I love it. And that one's congruent. Good. And Amanda, how about E?
Well, I think it's the R and S one because you have one side and then the middle side and then you have the angle.
You know what? I would agree with you if they had a little right angle here. Even one would be sufficient, but we don't know that it is or it isn't. So this is probably going to be what? No, it's side-side angle, so we would say not congruent. Do you see how it's different than this next one? So, Amanda, tell me about this one. That one is right angle, hypotenuse, and then another side. So that one's congruent. Very good. And how about, Alex, how about the G? Yeah, this is an angle, corresponding side. It corresponds to this one. So yeah, this is definitely going to be angle, corresponding side, or angle, side angle, because you would be able to figure out if these two are congruent and these two are congruent, that would make these two congruent, so you could say angle, side angle. Either one is fine. Congruent. And then the last one, Austin, what do you think of this one?
That one, you have multiple answers, but I said angle, side angle.
Let's see. So this one, you're going to have, this side is the same. And then these are parallel. So since they're parallel, these angles are going to be what? Alternate interior. So those are congruent. And then these guys are congruent. So it looks like we have angle, side, side.
No.
There's more that you know about that.
You have angle, side angle, because
Side angle. It was bound to happen today. I did it whole third hour. I didn't do that. Oh well. Okay. Here, I'm going to pause this. This one is embarrassingly easy. Explain why the triangles ABC, EDC are congruent. Tell me what we know and give me letters here. What do we know are congruent? Yes, BC is equal to CD because given, right? And so we know these two. What else do we know? The vertical angles. So angle BCA is equal to angle BCA DCE. Those are vertical angles congruent. Okay? And we know one more. One more. What's that? Yes, because these are parallel. And because they're parallel, then, let's see, which ones are we going to say are equal? Yeah, probably these two. So angle ABC is equal to angle EDC, and those are alternate interior angles, congruent, all right? And so if you have angle, side, angle, are we good? Since, we don't have to say since, we would say triangle ABC is congruent to triangle EDC because of angle, side, angle. Or you could just say angle. Yeah, I'm going to say angle, side, angle. And then it says if AC, this one's great. AC is 6. What's CE going to be? Ooh, that's tough. If BAC is 42, then what's this one up here going to be DEC? Yeah, this is further math. I can't believe that. Let's go to this next one. Everybody go to this one. This is as far as we'll get today. We're going to go ABC, and we're going to look at bisecting this. And to bisect it, we're going to make a little perpendicular here, and we're going to make a little perpendicular here to make those triangles. And it says point P is equidistant from both AB and AC. Drawing that, see if you can prove that those triangles are congruent. Go. Write it as clearly as you can.